when we talk about inverses, do you remember doing inverses? There's like a little snippet of inverses in Math 112 pre-cal. Do you remember if you had a function, f of x is equal to 3x minus 2, and it wanted you to find the inverse? Well, there were steps. Step number 1, make f of x go to y, because they're interchangeable. And then you're literally going to flip-flop the x and y, and then you resolve for y, and this is your inverse. Okay? So we're going to do this. We're going to try to apply this in trig. And what I want you to do in your book is I want you to get a grasp of what it is that we're actually doing. So if you look on page 246, that starts the inverses. But that really and truly starts talking about the 112 part. And if you look on page 247, step number 5 in that tan box, or number 5 in that tan box, those are the steps that I just did on the board. But I want you to get a picture of what an inverse is. So I want you to go down to figure number 2. And in figure number 2, you see the line y equals x. That's your mirror for an inverse, because that's what an inverse is. An inverse is a mirror image reflected across the line y equals x. So if you have an ordered pair AB, then an inverse is BA. Okay? And then you can have graphs like the one to the right. The blue graph would be your actual function, and then the red graph would be its inverse. But again, that is what's going on in algebra. So if you go to the bottom of the page and you see inverse sine function, that's where we're going to be as far as trig is concerned. We're going to do the inverses of all 6 functions: sine, cosine, tangent. And then the inverses of those. So look on page 248. At the top of page 248, what you see is the sine function. On the top of page 248, you see the sine function. And the sine function ranges roughly from negative 3 pi over 2 all the way to 2 pi. Well, if you remember, when you do an inverse, you have to do a horizontal line test, and it can only touch one time. So if we draw a horizontal line through that whole entire picture, figure number 4, it wouldn't be a function. So what we're going to do is we're just going to take a piece of that sine function. And the piece that we're going to take is going to go from negative pi over 2 to pi over 2. Now in that figure, in figure 4, this is your sine function, not the inverse. Okay? And so remember, when we talk about function versus inverse, do you remember what the domain is? If I gave you a set of ordered pairs, let's say 3, 2, 5, 6, and negative 1, 4, what would the domain be? The x values. So the domain is going to be 3, 5, and negative 1. What would the range be? What would the range be? What? Yeah, the y values, 2, 6, and 4. Well, if this is my function, what do you think the inverse function would be? What will be the inverse of this one? 2, 3. What about the next one? 6, 5. And then you have 4, negative 1. So now, what is the domain? 2, 6, negative 1. And the range is going to be 3, 5. Yeah, 3, 5, negative 1. So do you see what happens? The domain and the range, they literally flip-flop. domain and the range literally flip-flop. So if you look at your picture on the top of page 248, this is your sine function, but we're only going to use for our domain from negative pi over 2 to pi over 2. And the range, of course, for the sine function is always going to be from 1 to negative 1. For sine, you cannot go above 1 and you cannot go below 1, negative 1. Well, look down at figure number 5. Figure number 5 on figure number 5a, that is the slice that we took out of the sine function up top. And they just blew it up for you just a little bit so that you could actually see. Well, if that is the sine function, then letter B is the inverse of the sine function. And the main thing that you need to notice is this. What used to be the x-axis is now the y-axis. And what used to be the y-axis is now the x-axis. So in other words, your range for your inverse sine function is going to go from negative pi over 2 to pi over 2. That's now going to be your range. And that's important because when you find these inverses, you have to stay within the range. If you find something outside the range, then it doesn't exist because it wouldn't be a function anymore. Okay? So that's going to be your inverse sine function. And you see the word arc sine. Arc sine and sine to the negative 1, those mean the exact same thing. Those are both inverse. They both mean inverse. All right, so here is your inverse sine function. Notice the range goes from pi over 2 to negative pi over 2. Your domain goes from negative 1 to 1. It's important. Domain we're not really that concerned with. Range we're definitely concerned with. Okay? Now, range, if you look at your unit circle, if you look at your unit circle and the range goes from negative pi over 2 to pi over 2, you're thinking, okay, are we going to go from here to here, or are we going to go from here to here? Well, it's going to go with quadrants 1 and 4. Quadrants 1 and 4. All right, and then you have your cosecant. Your cosecant is the same thing. It's going to be quadrants 1 and 4. Or the range is going to be from negative pi over 2 to pi over 2. Now, this is what I want you to do. You have your unit circle out? Yes, no? Please get it out. What I want you to do is I want you to look in quadrant 4. And on our unit circle for quadrant 4 for 330 degrees, or 11 pi over 6, does 11 pi over 6 fall in the range from negative pi over 2 to pi over 2? Does it fall in this range? If I had to graph on the y-axis 11 pi over 6, where would it be? It would be way up there somewhere. Would it not? So, when we say in quadrants 1 and 4, we're not talking about here and then keep going all the way up to there. Remember, we're having to go here and here. So, from your unit circle, 11 pi over 6 is not in the range, but negative pi over 6 is. And so that's what you're going to do. Your range, you're going here. And then remember, if you go clockwise, it turns into negative rotation. And that's what you're doing. You're going positive rotation for first quadrant and then negative rotation for the fourth quadrant. So on your unit circle, I want you to write, for 11 pi over 6, I want you to write negative pi over 6, because that's going to be your inverse. Negative pi over 6. And then your 7 pi over 4, that's going to be your negative pi over 4. And then for your 5 pi over 3, that's going to be your negative pi over 3. And then, of course, your 3 pi over 2, that's going to be negative pi over 2. So, for your you're going to use 0 to pi over 2 and 0 to negative pi over 2. Quadrants 1 and 4. Okay? So let's look at cosine. You look in your book. And if you'll look over on page 250, you'll see the cosine, and you'll see the slice that we're going to use. Notice the only slice that we're going to use for cosine is going to be from 0 to pi. From 0 to pi. Because if you don't, that's when you draw the horizontal line, because remember, the cosine function goes like this. And in order to have an inverse function, you have to be able to draw a horizontal line. And you can't do it. So you have to use only from 0 to pi. So we cut it off here. That way we don't touch it twice. So your range for your inverse cosine is going to be from 0 to pi. It's going to be from 0 to pi. And we're going to be in quadrants 1 and 2. Quadrants 1 and 2. All right. And then we have tangent. Tangent and cotangent. Again, we're going to be in quadrants. For tangent, we're going to be in quadrants 1 and 4. But for cotangent, we're going to be in quadrants 1 and 2. Okay, so I know what you're thinking. You're thinking, OMG, I cannot remember this. Well, look on page 253, and you'll see a blue chart. If you want to, on the back of your unit circle or on the back of this sheet, whichever one you're going to use, copy that chart down. Okay? On your own time, of course. But either on the back of your unit circle or on the back of this table form of the unit circle, copy down that chart. And that'll help you a little bit, hopefully. Maybe. I don't know. Okay, so look at this. If I'm asking you to find the exact value for y, all right? So we have y is equal to tangent inverse of 1. Well, remember back in 112, what we did is we flip-flopped. So watch. What I'm asking is this. Tangent of what angle or what value is equal to 1? Tangent of what value is equal to 1? Well, first thing you need to know is this. Tangent inverse is in what quadrant or what range? Look at your chart. Tangent inverse is in what quadrant or what range? Yeah, 1 and 4. Tangent inverse is going to be in quadrant 1 or quadrant 4. Now, think about this, okay? Tangent of what angle is equal to 1? Is that positive or negative? Is 1 positive or negative? It's positive. So are we in quadrant 1 or quadrant 4? You're in quadrant 1. Because if it was negative, then you would be in quadrant 4, because tangent is only positive where? 1 and 3. A smart trick class? Tangent is only positive in 1 and 3. Well, 3 is not even an option. 3 will never be an option, by the way. You either have to be in quadrant 1 or quadrant 4. Since your 1 is positive, you're in quadrant 1. So let's focus on quadrant 1, okay? Look at your unit circle. And remember, tangent is what over what? All answers are correct. Tangent is what over what? All of these are correct. So what I want you to do is I want you to look at your unit circle in quadrant 1. And you have your ordered pairs written out there, yes? Everybody has the ordered pairs? Put your y coordinate over your x coordinate for all 3 of these. Which one's going to give you 1? What? Well, exact value, so we're talking about radians. So your answer is going to be pi over 4. Pi over 4. Because radical 2 over 2 over radical 2 over 2 square root of 2 over 2 divided by square root of 2 over 2, anything divided by itself is 1. So this is pi over 4. Okay? So y is equal to tangent inverse of 1. So y has to be pi over 4. Y has to be pi over 4. Okay? So now let's go to cosecant. First thing we need to do is we need to figure out the range for cosecant. When we talk about cosecant, what quadrants are we talking about? Look at your chart. Look at your notes. For cosecant, inverse cosecant, which quadrants are we talking about? 1 and 4. Okay? Next thing I want you to do is look at this. Square root of 2. Is it positive or negative? It's positive. So think, we're either in quadrant 1 or 4. Which one of those is cosecant positive? 1. Because in quadrant 4, what's the only thing that's positive? Cosine. It's not cosine. So we're in quadrant 1 again. Well, let's rewrite this, because what we're asking is cosecant of what is equal to the square root of 2. Well, what is cosecant? Everything's right. What is cosecant? 1 over sine, r over y, however you want to look at it. Okay, so cosecant is going to be 1 over sine, r over y, whatever you want to do. But which angle in quadrant 1 is the only one that has the square root of 2 in it? Which angle in quadrant 1 is the only one that has square root of 2 in it? Pi over 4. Do you see what I'm doing? Figure out what quadrant you're in. Once you know which quadrant it is in, then you have to know either your y over x, r over y, whatever the case may be, and then figure it out. Well, watch this. I'm thinking that since there's a radical 2 in there, I'm thinking that we're looking at 1 over the square root of 2 over 2, because that's cosecant is 1 over sine. But sine, cosecant is 1 over sine. But cosecant is also 1 over y. The y coordinate, well, pi over 4 is the only one, so let's check it. We're going to have 1 over the square root of 2 over 2. Well, that's going to be 2 over the square root of 2. Let's rationalize. We're going to get 2 over the square root of 2 over 2, and you get the square root of 2. So it checks. So it has to be equal to pi over 4. Now, do you have to go through all that? No. I'm just trying to prove to you that it actually is pi over 4. Okay? See if you can do cosine inverse of negative 1. Cosine inverse of negative 1. Now, we're not in a quadrant, and that's okay, and I'm going to show you why in just a second. Basically, you're asking yourself, cosine of what is equal to negative 1? Cosine of what is equal to negative 1? Well, cosine is which variable? Which coordinate is cosine? Which coordinate represents cosine? X. X coordinate represents cosine. Go around your unit circle and find an x-coordinate that is -1. Find an x-coordinate that is -1. Do you see it? What is it? It's pi. So y has to be equal to pi. Now, go to your chart on page 253 and look at cosine inverse. And in particular, look at the range. You see the brackets around 0 and pi? What do brackets mean? Can be equal to. Because look right down below it for tangent inverse, and you see parentheses. You see those parentheses? Parentheses mean what? Cannot be equal to. So, cosine inverse doesn't necessarily have to be in a quadrant. It can be on the axis. In this case, it is. It's going to be pi. All right? Look at this one. You have y is equal to sine inverse of -pi/2. First thing I need to know is what quadrant are we in? Inverse sine is in what quadrant? 1 and 4. 1 and 4. If you're wondering where we're getting this from, go to page 253 in your book, or you should have written it down in your notes. Either way. Quadrants 1 and 4. But look, we're looking at negative radical 2/2. Where is sine negative? Quadrant 4. Certainly not 1, right? So we're definitely going to be in quadrant 4. And remember your range for quadrant 4 for sine is going to be from 0 to -pi/2. Okay, so don't spit at me something like a 11 pi/6 or 7 pi/4. That's way out of our range. Okay, so let's rewrite it. We're saying sine of what is equal to negative radical 2/2. What coordinate represents sine? The y coordinate represents sine. Okay. So, look down in quadrant 4, and do you see a y coordinate that is negative square root 2/2? So what is y equal to? Negative what? Negative pi/4. Alright, let's look at secant. So we have, basically we're saying secant of what is equal to negative square root of 2. Negative square root of 2. Secant inverse is what quadrant? Secant inverse is what quadrant? 1 and 2. Secant inverse is in quadrants 1 and 2. But secant is negative. Can anything be negative in quadrant 1? No. Nothing can be negative in quadrant 1. So we have to be in quadrant 2. So focus on quadrant 2. Focus over here on quadrant 2. Now, again, secant is what? 1 over cosine or 1 over x. So, what do you think? Well, we're looking for y. We're looking for a radian measure. What? Very good. 3 pi over 4. 3 pi over 4. Because 1 over the x-coordinate of 3 pi over 4 is going to be negative radical 2/2. And we did this math a while ago. And it comes out to be negative radical 2. Okay? Cotangent. Where is cotangent good? Which quadrants are we talking about? Cotangent's good in 1 and 2. Quadrants 1 and 2. But the cotangent that we're looking for is negative, So which quadrant do we have to be in? You have to be in quadrant 2. So let's focus on quadrant 2. Now, cotangent is going to be what? Tell me all the things that you know about cotangent. It's x over y, and that's probably going to be the one that we're going to use. What else do you know? Cosine over sine, 1 over tangent, which that one's kind of irrelevant here. Okay, so x over y. So this is what I'm going to do. What quadrant are we talking about? Quadrant 2. In quadrant 2, what I want you to do is I want you to look at the 3 ordered pairs. Which of those ordered pairs have the square root of 3 in them? There's 2, right? There's 2 ordered pairs that have the square root of 3 in them, right? Well, this is what you need to do. You need to do some math here, okay? You're going to put the x coordinate over the y coordinate and simplify as far as you can. Whichever one of those 2 gives you negative square root of 3, you got the answer. You got the answer. So the first one I'm going to try is 2 pi over 3. I'm going to get negative 1/2 over square root of 3 over 2. Well, if I do some math, I'm going to get negative 1 over square root of 3, skin over guts, the 2's cancel out. And then if I rationalize this, I'm going to get negative square root of 3 over 3. That's not what I'm looking for, am I? Because I'm looking for negative square root of 3. Well, let's go back and try 5 pi over 6. 5 pi over 6, the x coordinate is negative radical 3 over 2. And the y coordinate is 1 over 2. Again, if we do skin over guts, the 2's are going to cancel out and you get negative square root of 3. There it is. So what is y equal to? 5 pi over 6. So sometimes you have to do some math. Sometimes you can just look at the coordinates and know what it is. Okay? So now, let's do the sine of an inverse. Let's do a trig function of an inverse trig function. So, what I'm going to do is I'm going to let the embedded function equal theta. So really and truly what I'm looking for is sine theta. Okay? So basically what I'm saying is theta is equal to arc cosine, cosine inverse, same thing, of 1/4. So basically cosine theta is 1/4. Cosine of theta is equal to 1/4. Okay? So when we talk about the inverses here, what quadrant are we talking about? Cosine's only good in quadrants 1 and 2. Cosine's only good in quadrants 1 and 2. But look at cosine. It's positive, so what quadrant do we need to be in? We need to be in quadrant 1. Okay? So, to do an embedded function, look at what we need to do. If we have a theta in quadrant 1, okay? If we have a theta in quadrant 1, and we've already determined all of that, cosine is what? Adjacent over hypotenuse, or x over r. So we're going to have 1 over 4. So there's your cosine, but we don't need cosine. What do we need? We need sine. We don't know opposite over hypotenuse. We know the hypotenuse. We already know the denominator is going to be 4. But now what we've got to do is we've got to figure out what the side opposite is. How are you going to do that? You have a right triangle. One side's missing. Always to find the one side missing of a right triangle, what are you going to do? Pythagorean theorem. So we're going to have a squared plus b squared. Well, we don't use that anymore, do we? X squared plus y squared is equal to r squared. Alright, so x is 1, 1 squared is 1. y squared is equal to r squared, which is 4 squared, which is going to be 16. So y is going to be the square root of 15. And you just did it. Okay? So use your embedded inverse function to figure out, number one, what quadrant you're in, and number two, to set up a little diagram. Once you figure out that diagram, sometimes, not always, most of the time, you'll need to do the Pythagorean theorem and figure out the other side. Once you know the other side, you're good to go. Sine is opposite over hypotenuse, or y over r, however you want to look at it. Okay, so let's look at this one. Again, we're going to let this be equal to theta. This whole thing is going to be equal to theta. So we're looking for secant theta. So therefore, theta is equal to sine inverse of negative 1/5. Inverse sine is in what quadrants? 1 and 4. But it's negative, so what quadrant do we have to be in? 4. Negative 1/5. Since it's negative, we have to be in quadrant 4. Have to be in quadrant 4. Okay? So sine of theta is negative 1/5. Okay? So let's draw us a theta in quadrant 4. And let's turn it into a right triangle. So sine is going to be opposite over hypotenuse. So negative 1, which is your y, over 5, which is your r. We need secant. Secant is what? Secant is the inverse of cosine. Cosine is x over r. So secant is going to be what? R over x. We don't know x, do we? It's right here. We don't know what it is. So let's use the Pythagorean theorem. So we're going to have x squared plus y squared, negative 1 squared is 1, is equal to 5 squared, which is 25. So x is going to be equal to the square root of 24. Let's go ahead and rationalize that. So we'll have 2 radical 6. So secant is r over x, which is equal to 5 over 2 radical 6. Is it positive or negative? Secant in quadrant 4 is positive. So we're good. All right, let's rationalize. So we're going to have 5 radical 6 over 12. Okay, so let's talk about it in terms of u. You will see this. How many of you are going into Cal 2? You will see this in Cal 2. You will see this in Cal 2. In terms of u, same thing, same process. We're going to let this be theta, so we're going to be looking at cosine theta, which is going to be x over r. So that's our goal. Cosine theta is going to be x over r. Well, if theta is equal to tangent inverse of 3 over u, that means that tangent is equal to tangent theta is equal to 3 over u. So this is going to be y over x. So let's draw. What quadrant are we in? When we're talking about tangent inverse has to be in quadrant what? Tangent inverse has to be in quadrant 1 and 4. Since it's positive, we're going to be in quadrant 1. So we're up here somewhere. So here's your theta. Tangent is going to be opposite, which is 3, over adjacent, which is u. But what do we need? We need to find r. We need to find r. R squared is equal to 3 squared, which is 9, plus u squared, which is u squared. So r is equal to the square root of 9 plus u squared. So cosine theta is going to be x, which is u, over r, which is the square root of 9 plus u squared. Now, we need to rationalize this, because we can't have a radical in the denominator. So, let's multiply by the radical. This is algebra stuff. So we're going to have u times the radical, because you can't multiply those together. And then when you multiply a radical times a radical, what happens? Square root of 3 times square root of 3 is what? 3. The radical just goes away. So you get 9 plus u squared. This is the study guide. This is what's on Blackboard now. This is